Welcome back to another explainer. If you're building AI agents right now, you are definitely familiar with the massive headache we all keep running into. It's this constant tug of war. You either have to pick a massive, sluggish model that reasons brilliantly but completely burns through your compute budget, or you go with a tiny, super fast model that just completely falls apart the second things get complicated. But what if you actually didn't have to choose? Today, we're tearing down a brand new solution to this exact problem: NVIDIA's Nemotron-3 Nano. Let's start with a number, 99.2. Literally 99.2. That is the mind-blowing score this model just dropped on the AMI 25 math benchmark when using tools. AMI is notoriously brutal, right? So what we're looking at here is a brand new heavyweight champion, but it's hiding inside a lightweight, insanely efficient package. Okay, let's dive into this. To give you a quick roadmap of the explainer, we're going to first meet Nemotron-3 Nano, peek inside its hybrid architecture, master its agentic reasoning, uncover that massive training recipe, check out the benchmark results, and finally, get you ready for deployment and quick start. So step 1. Meet Nemotron-3 Nano, the new standard for AI agents. Released just back in December 2025 as part of NVIDIA's open model family, this isn't just another incremental update. NVIDIA actually trained this unified model from the ground up, entirely from scratch, specifically to juggle both deep, complex reasoning and those really fast, non-reasoning tasks. It's practically tailor-made for the totally unpredictable dynamic workflows of autonomous agents. And it's wildly versatile. We're talking fluency in 6 spoken languages, including German, Spanish, French, Italian, and Japanese, plus an absolutely crazy 43 different programming languages. All right, moving on to part 2, let's look under the hood, inside the hybrid architecture, the Mamba-2 transformer hybrid. The best way to think about this architecture is honestly like a giant iceberg. On paper, the model packs a massive 30 billion parameters. That's your deep knowledge base, sitting hidden below the water. But, and here's the real kicker, for any single token it actually processes, only 3.5 billion parameters are active. That's the sheer magic of the mixture of experts, or MoE, design. You are basically getting the massive brainpower of a 30 billion parameter model, but with the blazing fast inference speed of a 3.5 billion parameter one. So how is that actually structured? Well, the whole thing is a brilliant 52-layer hybrid design. You've got 23 Mamba-2 layers driving the ultra-fast sequence processing, 23 of those MoE layers for the deep knowledge retrieval, and 6 standard attention layers tying it all together to keep things focused. And inside those MoE layers, it is a masterpiece of computational routing. You have 128 routed experts plus 1 shared expert, and the model dynamically wakes up just 6 of them per token. It's just incredibly efficient. Which brings us perfectly to our third section, mastering agentic reasoning. Think first, act later. Now, this is the core superpower you need to know about. When Nemotron gets a prompt, it can actually generate an internal reasoning trace, like a literal thought process, before it spits out the final answer. But as developers, we all know latency is king, right? You can't have a model thinking forever. Enter the reasoning budget. This is a totally new configurable parameter that lets you put a hard cap on that internal thinking time. It will try to wrap up its thoughts at the next new line, and if it can't, boom, it strictly cuts it off 500 tokens later. If you're building autonomous agents or customer support bots where every single millisecond counts, this is an absolute lifesaver. And the best part is that it's completely in your control. You can just flip reasoning totally off for maximum speed. Sure, you might see a tiny accuracy drop on really complex stuff, but you get instant answers. Or flip it on and give the model the breathing room it needs to crack multi-step logic puzzles. You basically get absolute flexibility to perfectly match whatever your latency budget demands. Section 4. Let's talk about how this thing was made. The massive training recipe, forging the champ. Look, you do not get benchmark-crushing performance without a ridiculous amount of data, and NVIDIA absolutely brought out the heavy machinery here. 25 trillion tokens. Just let that number sink in for a second. That is the staggering volume of data Nemotron-3 Nano chewed through just during pre-training. It's enough to build this incredible, rock-solid foundation of general knowledge, math, science, and coding long before it ever even started learning how to act like an agent. The actual training pipeline happened in 3 distinct stages. Step 1 was that massive pre-training run using Megatron-LM. Then, step 2 was supervised fine-tuning. Here, they used NVIDIA's Data Designer library to really hone in on agent skills like tool calling and generating structured outputs.
Finally, step 3 is where the real magic happens: reinforcement learning. They deployed synchronous GRPO to evaluate how well it used tools over multiple steps, and then smoothed out the conversational tone using RLHF. Basically, they used human-guided feedback to make sure the model is actually helpful and safe to use.
Now, if we zoom in on the 10.6 trillion token post-training dataset, there is a super fascinating split. About 3.5 trillion of those tokens are purely synthetic data, distilled directly from much larger teacher models. But they didn't just dump all that generated text in blindly. They aggressively filtered it. We were talking strict automated verification using actual compilers, complex numerical checks, the works. They ensured only the absolute highest quality data made it into the final mix.
All right, Section 5, Benchmark Performance Results, the scoreboard.
So what does all this crazy architecture and massive data actually translate to in the real world? Well, when you stack it up against heavy hitters like QN3-30B and GPT-OSS-20B, Nemotron-3 Nano completely dominates as an autonomous agent. I mean, it scored a massive 38.8 on the SWE Bench Open Hands evaluation for coding, just absolutely crushing the competition. And on the BFCL v4 benchmark for agentic tool use, it hit an unmatched 53.8. The data proves it. This thing is an absolute powerhouse for dynamic developer workflows. Which leads us to our final stop, Section 6, Deployment and Quick Start, putting Nemotron to work.
NVIDIA made integrating this powerhouse incredibly straightforward. Right out of the gate, you've got full support for Hugging Face transformers. It is heavily optimized for vLLM, NVIDIA's own TensorRT-LLM, and even Seaglane. But honestly, the most exciting bullet point here, it supports a jaw-dropping 1 million token maximum context window. Think about that. You can literally feed this model your entire codebase, massive financial reports, or huge rulebooks, and it can reason over the whole shebang in a single prompt. That is a real game changer. So as we wrap up this explainer, I want to leave you with a question to chew on. How are you going to budget the reasoning time of your next AI agent? Because now, with Nemotron-3 Nano's reasoning budget feature and that super efficient active parameter count, the constant trade-off between lightning-fast latency and deep, complex thought is finally entirely in your hands. Thanks so much for hanging out with us, and we will see you in the next explainer.